Good morning and welcome everyone to the ETC. My name is Nanette Hogue-Covington. I'm the Executive Director of the ETC Foundation. Welcome to Canada Climate Week Exchange, or CCWX. We're hosting it here at the ETC in collaboration with the Clean Resource Innovation Network, or CRIN. CCWX is a national initiative that brings Canadians together for 1 week each year to collaborate on solutions to our country's unique climate challenges. This week is about accelerating made in Canada's innovations that strengthen our economy, communities, and environment. First off, I'd like to acknowledge the lands that we work, live, and play. In the spirit of respect, reciprocity, and truth, we acknowledge that we gather on the traditional territories of the people of Treaty 7 on the southern or in southern Alberta. This includes the Blackfoot Confederacy, comprising the Siksika, Kainai, and Piikani nations, the Tsuut'ina Nation, and the Irahe Nakota nations, consisting of the Chiniki, Bearspaw, and Goodstoney. We also recognize that Calgary is home to the Otipemisiwak Métis government of the Métis Nation within Alberta, particularly districts 5 and 6. We honor the original caretakers of this land, known as Mohkinstsis and Blackfoot, and acknowledge all Indigenous and non-Indigenous peoples who live, work, learn, and play here. May this acknowledgement remind us of our shared responsibilities to reconcile and build respectful relationships with Indigenous communities. At the ETC, our mandate is to empower innovators and small to medium enterprises by fostering the ecosystem where ideas can scale into impactful solutions. The ETC, because we're additive in the energy technology development. We believe innovation thrives when we embrace the 3 Cs: community, connection, and collaboration. These values are the heart of our partnership with CRIN, a national network dedicated to advancing clean resource innovation across Canada's energy sector. Together, we create pathways for scalable, clean technologies that position Canada as a global leader in sustainable resource development. Canada's energy and resource sectors are a pivotal moment with a world-class research capabilities, entrepreneurial talent, and strong collaborative culture. Canadian industry is leading the charge in developing clean technologies that can be deployed at scale, not just here at home, but globally. These innovations are critical to achieving climate goals, enhancing competitiveness, and ensuring prosperous, sustainable future. We're holding many events here during CCWX week, and we're proud to host a series of events showcasing Western Canada's leadership in clean technology and climate innovation. I'd like to highlight the events throughout the week, including this morning, Canada Cleantech Showcase running till 10 o'clock, featuring panelists from Tourmaline, Emissions Reduction Alberta, Accelaware, Kinetics, and the Government of Alberta. And then we'll have a technology panel from 11 o'clock onwards, and then the Clean Tech Innovation Showcase from noon till 3. And then tomorrow, we will be hosting the Practical Climate Solutions hosted by PTAC and enabling a bunch of success stories in our sector. And then next, we have EFL, so Energy Futures Lab will be hosting Wednesday, and Why the West, Unlocking Western Canada's Climate and Carbon Competitiveness in the Critical Minerals Value Chain, alongside TMX Group. And on Thursday, Mila will be hosting a session. These events reflect CRIN and ETC and our ecosystem partners' roles as catalysts for Calgary's evolving energy sector, uniting startups, investors, industry leaders, and researchers to drive breakthrough solutions for a cleaner, more resilient energy future. So just a few housekeeping things before we get started. Just in case there's an emergency called, we are convening outside. The muster point is just on the west side of Center Street, just past outside our building. So as you exit, turn left. The washrooms, just to let you know, the men's washroom is over to the left, and you'll see signage along the way. Women's washrooms, you have to exit the floor, and the washrooms are headed that way. And you do need to grab a couple passes before you head out the door so that you can access the floor again. And then the name tags you'll be receiving or have received, please return them at the end of the day. Next, we'll be hosting our tech showcase, and I'd like to call upon Dean Pick from Kinetics.
Thank you, Nanette. Could we queue up the slide deck, please? So I'm going to be highlighting a project that we did with ERA, CRIN, NGIF, and a few of their commercial partners, which was to bring a spring-loaded electric valve actuator to the natural gas sector. Talk a little bit about kinetics automation. Our company, we deal in process control and automation equipment. We are based in Vancouver, BC, with manufacturing there, and we keep a sales office here in Calgary. What we do is we apply technology known as shape memory alloys to industrial products, and this allows us to do a variety of things, including automate process control equipment. And it was back in 2019 that we were approached by the Canadian Gas Association, specifically through their innovation arm, NGIF, who brought to our attention the problem of venting pneumatics. So venting pneumatics are the operation of these valves, shown schematically here as basically pneumatics, which are actuators which lift and drop to open and close a valve. They are normally spring return, and the industry, the natural gas industry, has been heavily reliant on the use of natural gas from the pipeline, and that's known by a variety of different names, such as fuel gas, instrument gas, but effectively it's methane. It is the product that the companies and the supply chain are trying to deliver to the customers, but the use of this equipment, venting pneumatics, creates not a leak point, but an intentional vent point. So that's a release to atmosphere of this natural gas. And through the operation of these devices, they have been a chronic source of downtime and maintenance. So everything from frozen lines, so that's the fuel gas line literally freezing up. It tends to be a wet gas, particularly at production sites, to fouled controllers. Those are the pneumatic computers that run mechanical computers that run the open and closing, to cracked diaphragms, et cetera. I can keep going on ad nauseum. But what's really been, I'll say, spurring change in the industry is regulatory changes, where methane release direct to atmosphere has been, targeted with things like Directive 60 in Alberta, preventing the use of pneumatics for greenfield sites. Then we see the BC government with Regulation 282 now addressing it through basically mandatory phase out by 2035. And then with Saskatchewan's PNG 36, we now have regulatory framework for across Western Canada. PNG 36 in Saskatchewan, by far the most aggressive regulation in terms of rollout. As of this calendar year, companies are expected to show 25% reductions across baseline, and that carries on year over year, 25%, until we get to the end of 2028, where they're looking for a complete elimination of venting pneumatics. Now, something to keep track of is new equivalency agreements that are under discussion between the province of Alberta and the government of Canada. We'll see if there are new announcements in this calendar year to start to attack or address the legacy or the installed base of these devices, because the numbers are high, estimated into the hundreds of thousands in this province alone. Currently not yet under regulation for elimination, just under regulation for limited venting, otherwise known as low bleed. So we were asked to apply our technology to solve this challenge of venting pneumatics, and we came to market back in 2024 with the KVA 38. So this was intended to help both the brownfield and the greenfield problem. It is an electric spring-loaded actuator, something that sits on top of the valve, also shown here just behind me on the banner, as well as in the photograph here. What it does is it replaces pneumatics, it replaces venting pneumatics also or specifically with an electric alternative without sacrificing the way that these devices are meant to operate. That is power to lift and then spring return to close, giving you reliability in the event of power disruption, control system disruption, any kind of failure in the line. It is a certified product for Class 1, Zone 1 for legacy sites that would otherwise or could be known as Class 1 Div 2. And really what we heard from the operators is, yes, make it safer, yes, make it better so that it's reliable, but also, make it cost effective. So our approach with this was to basically make it competitive on upfront CapEx with other equipment such as motorized valve actuators, while still providing additional value adds such as spring return and a built-in positioner. But through its unique design, which only has one moving part inside, we can provide much higher uptime. So that means availability, which means more production through your systems. And we can also provide basically lower maintenance costs. So it is a maintenance-free device. This keeps your crews, your maintenance crews on other problems, other sites. We appreciate that a lot of these, particularly at the remote gas plants, production sites, et cetera, need to operate around the clock without constant supervision. So through this, we've tried to bring basically the next generation of valve control, process automation to the natural gas industry. And every unit that we can install, particularly in brownfield, we can eliminate a venting actuator. That's 1 ton of methane per year that we can keep out of the atmosphere and keep in your systems so that you can deliver it on to your customers and ultimately obtain, retain revenue benefits as well as reduce maintenance. So when we talk about larger facilities, particularly, let's say, enterprise scale, some of the studies we've done for the larger operators show savings in the millions of dollars, both through a combination of retained gas revenue, reduced maintenance, and higher production in the form of higher throughput and availability. So we were fortunate to be involved with the NGIF program. This allowed us to deploy at the Emission Testing Center, which was set up by Tourmaline. A lot of people are familiar with their gas plant, ETC, but they've extended that envelope or umbrella, if you will, to also capture production sites. So back in 2022, we deployed to a separator shack at a new production site where we had 3 prototypes running. We went in on an iterative process after listening to the feedback from the operators as well as the technicians, and came back with an improved commercial product shown here on 2 dump valves, as well as there being a third actuator not shown in the photographs, but around the corner doing back pressure control. So we did a study since March of 2024 where they went in, monitoring their performance, monitoring their uptime. And through this demonstration site, we were able to show good uptime with no maintenance calls, good uptime with no loss of availability, and basically showed good efficacy on different applications such as level control, where we had these 2 devices controlling the level of a separator tank. So that's directing the flow of liquids like condensate and produced water into tanks or into downstream gathering systems. Those were cycling units, so on, off, on, off. You can see their power consumption low or medium single digits. That's because when they're closed, they're idling and take no power. We're relying on the spring inside these units to hold them closed, and they work in blackout conditions. Compare that to the back pressure control, which is a different application. It's throttling open, throttling back to control the pressure drop. In this case, we are always on, always moving. So it's a much different performance. And you can see we're operating under about 80 watts of consumption. So if you look at our ability to service this particular shack, we were able to do all the automation demands with the one exception of choke valve, which we are looking to address with new products. Ultimately, though, servicing this shack with under 100 watts of power consumption. That being an important number because we understand that for these remote sites, it does take money to electrify them, either in the form of high power lines or alternative sources such as solar, battery, or electrical generation from natural gas. The story of Kinetics Automation, at least with respect to the energy sector, has been a 6-year journey. We've really benefited in a variety of ways, including a close partnership through the top box here, which involved everything from University of Calgary with Ian Gates's lab, where they provided us environmental testing, all the way through to live field testing with a number of the operators shown here under the NGIF accelerator. We were also fortunate to receive non-dilutive funding from NRC IRAP in addition to CRIN. So this allowed us to bring the product to market without passing the burden of those upfront costs down through the product in the form of like a prorated cost, ultimately making the product more affordable for operators. We also took in a dilutive investment from NGIF Cleantech Ventures and now count quite a few of their LP partners as customers of ours. To get the product to market, we've established a relationship with CVS Controls sales office here in Calgary with facilities now in Nisku. They just moved out of Edmonton. Beautiful facility, 150,000 square feet. They can now ship units directly to site for brownfield, or they can integrate into a valve actuator combo package for greenfield or retrofits and ship a combo, basically fully automated valve to your sites for easy connection into your lines. Happy to say this is also a story of expansion and export. We are now exporting products into the USA. We've been just approved into the current cohort of the Rose Rock Bridge program, which is an Oklahoma-based company. So we're able to kind of repeat this success into the US market, where we have just established our first sales office in Tulsa and look to land and expand into that region. So for any operators, engineering companies, or anyone in the supply channel looking to connect, we have representation in Calgary as well as Edmonton. Please look us up online, drop us a note on our email or on our social channels. We'll be happy to connect and pick up the conversation. Thank you.
Thanks, Dean. Very informative. We all know how to find you too, so that's even better. I'd like to introduce Mark. I just met him a moment ago. I apologize. We now have Accelerator. Oh gosh, I need more coffee is what I need. Introduce Mike Tournier from Accelaware. So Mike, please welcome to the stage.
Thanks, Nanette. Thanks, everybody, for getting here. And for those of you who stayed home, maybe a smarter choice, but I'm glad I managed to make it here at least before it was my turn to get up here. So I'm going to walk through more of a process view of some of what we've done. We have worked, had support from ERA, from CRIN, from SDTC, and from Alberta Innovates as well in developing our technology. And then hopefully through the panel, we can talk about how we're now applying that technology out to other industries. It's coming soon, I know it. Oh, I'm in charge. There it is. Everybody read fast? Okay, good. So at the highest level, Accelaware develops essentially a power to heat technology that generates electromagnetic energy for industrial process heat. So, and when we talk about economically decarbonized processes, what we mean by that is we want to be competitive or lower cost than gas combustion in North America. That will let us be way lower in the EU and other markets, but that's kind of what we mean by it, is you got to be at least at the same cost or cheaper in decarbonizing for that to actually happen. There we go. And when we look at the global context, this is a huge market. If we talk about all the industrial process heat out there, probably 15% of global emissions, giant markets, huge amounts of installed base of capital that are out there doing all this heating, and really in a pretty archaic method. You're burning gas at 2000 C and then trying to aim that somehow at the thing you want to get hot, whether you're pointing hot air at it, directly heating it with a flame, or you're heating the water or some other heat transfer media and then rubbing that on the thing that you want to get hot. So it's pretty messy and there's a lot of waste energy. So now I'm going to step way back to our journey. We started out working to decarbonize heavy oil and oil sand production by eliminating steam generation at surface and creating it in situ with this electromagnetic energy. So we've been working on that since really, way back to 2010, but in earnest with the technology we have now since about 2016. We have completed a $30 million pilot. That's where all that support from the various funding agencies came in. We also had 3 oil sand operators, Suncor, Cenovus, and a third major involved in the project. But I wanted to use this slide because as we go through the panels, there's some questions about, how do you engage with collaboration with industry to get things done, and what does it take to get it commercialized? We're still working on that. So our first pilot, while very successful, had some issues with water getting into the heating line. So we deliver energy through effectively a coaxial cable that goes down 500 meters-ish and then goes off through the formation. But that limited our power, so we need to go back and redo that. But when we look at the context here of 13 years and $32 million, we achieved a ton in that first pilot, but we still need a second one. And so, when we get to the panels, we can talk a bit more about that. We proved the energy delivery worked. We proved we could get heat in there, but at 10% of our total power, that's not enough to make hot oil come out of the ground and have oil companies start buying this to produce their heavy oil. So our next step right now is, and this will come up again, I think, in the how you achieve commercialization, is we're now looking to get farm-in agreements of our own. We ended up having to be the operator of our first pilot and find our own site to go and deploy, albeit with the support of the 3 majors, but we had to go and do that to get it done. And we're going to do it again to finish that commercialization path here on the heavy oil side, at least. And then shorter, we think, I guess, one of those honest comments is that 5 years ago, we thought we were 1 year away from commercialization. We still think that, but we're much more confident now. Back then, it was easier for me to make a really cool comparison to SAGD development timelines that were 20 years and we were going to be 10. It's getting tighter, but we're still going to try to come in underneath that 20-year number. So here's a picture of how it works on the heavy oil side. And really, what we're doing is we are eliminating a lot of waste heat and the heat transfer media. So this electromagnetic energy goes in, flows downhole, and then it goes out and heats the water that's there. So we're not burning gas, making steam, pumping steam down the well and into the formation, and then pumping a whole bunch of that steam back out to reheat. We do produce some water, but the ratio typically is reversed. So steam oil ratio of 3, we would end up producing, instead of 3 parts water to 1 part oil, we're going to produce the reverse, 3 parts oil and 1 part water. So what we managed to accomplish in that first pilot is we think we figured out all the flaws we had in the deployment system going in the subsurface. At the surface, our core electronics worked flawlessly. We've proven that out to TRL9, so we're ready to scale up here, and we're ready to transfer this technology into other industries, and we'll talk about that in a couple slides. But in the process of doing this, and back to that slide with all the bubbles along the way, we've had several bumps where we thought, here's a design, here's a candidate design to go and resolve all the issues. We tested that really hard. We ran it through all of our operating partners' technical teams. And in one case there, it took us 2 years to go through that process, get feedback. No, that's not good enough. You've got to go back and be stronger, be better, and reduce risk further before you go on the ground. So we've done that. The new technology will see us put coiled tubing into the ground, so we'll be hermetically sealed from the surface all the way to the toe of the heating well. So we're quite confident that can eliminate our big single problem, which was water getting into the heating well. So now we can get all that energy into the well. But in doing so, we were able to reduce the capital cost of the wells, reduce the drilling cost, make it easier to install, and allow for more of that capital to be redeployed. The investment we've put into all our electronics, which live in the blue box at surface there, is that's a 20 to 25-year lifespan piece of equipment, so we can move from well to well or site to site to keep producing, and then the top half of the well would also be able to come out and go be redeployed at that next site. Here's a picture of the actual technology, and here's where we start shifting into generically industrial process heat. So that we built 2016-17 using what was the state-of-the-art silicon carbide transistors from GE. They've exited the business. Wolfspeed and Danfoss are probably the leaders now in that space. But like other electronics, power is improving and cost is decreasing per unit of power. So what we built there is a 2 megawatt unit we deployed in the field. We could deliver the same amount of power in less than half of that footprint. And we expect to see that scale continue to improve as well as the cost structure. So that machine takes electricity in, and its huge advantage is that for these big industrial scale processes, it can put almost all of those electrons into the ground as useful heat. So people have tried this technology, or in other industrial processes, they've tried microwaves. They can work really well at a lab scale, but they lose 30+% of that energy just converting into microwaves. We lose less than 2. So we have a significant advantage there, and we can scale up to many, many megawatts of power to support really large processes. So we started in heavy oil, and it took us, as you could see from the timeline, it's taken us a number of years to get to where we are now, which is TRL 8. Many of those years were on the electronics and a lot of years on the subsurface. As we went through the process, and in fact, while we were de-risking the heavy oil application, we knew we had to figure out if this energy delivery system was going to work. So we went out and we dug a ditch 50 meters long, and we filled it with mini versions of our lines and a smaller power inverter to deliver the energy. And we made a ditch of wet sand. And that was our measure. We can heat wet sand. Well, we can heat subsurface sand, rock, water. And we did that really successfully. Nice mid-February week of testing, minus 22-ish on the prairies. And we managed to not only heat, but completely desiccate that 50-meter ditch, which then had some light bulbs going off for us as, hey, we can dry things also with this technology because we can preferentially heat the water, not the material. So we knew that was a possibility. And then about 3 years back, International Minerals Innovation Institute out of Saskatoon, they had been talking to people at COSIA who said, hey, you should maybe check out Accelera. They've got this heating technology. And they asked us if we could use our technology to dry potash. So we've been now working with BHP, Nutrien, and Mosaic through the IMII for 2.5 years, building pilot systems of increasing scale and complexity to electrify their process and dry that potash more efficiently from an energy perspective and a cost perspective than combustion. That was our number one branch out into a new application. And the second one was amine regeneration or carbon capture. So in that scenario, we had always thought we could find a place to fit into the carbon capture space, but it was actually somebody at Suncor that introduced us to a project they were working on, the AIP with Innotech, and said, you should maybe talk to them. So we've talked to Innotech, we've done some of our own testing and development work, and we think we have a really significant advantage here where, again, when we look at each of these steps and we think back to what the fundamentals of the thermal engineering are, in amine regeneration, we can preferentially heat an amine molecule compared to the rest of the things that are in that liquid, and specifically a loaded amine molecule, so that we can put energy where it's needed to break the bond between amine and the CO2 and release that CO2 and then allow amine to be recycled. But we can do it at lower temperature and much lower energy to really reduce the cost of carbon capture per ton. I really have to press that button hard. So to paint a really simple picture here, talked a bit about that preferential heating, and here's how that works in the potash example. So as an example of a 100-ton-an-hour process, for a combustion dryer, they are going to heat 95 tons of ore, 5 tons of water, about 10 tons worth of drum, and probably some other surrounding space when they're burning gas to make hot air to blow through there. And most of that energy is going to go out the back and vented into the atmosphere. So when they're doing that, they're about 1.7 kilowatt hours per kg of water. It can be a little higher or a little lower, but mostly higher. And some price estimates there based on, I don't even remember which power rate, probably $100 a megawatt. And sorry, it's on the bottom. And then when we're heating with electromagnetic energy, we're going into that dryer. We have to change the format of the dryer to deliver the energy, but we get to go in and heat 5 tons of water. That water will conduct heat to the rest of the mass, but the bottom line still is the amount of energy that we need to put into that system is far less because it's going directly to the water. It hits the water first, whether it vaporizes it or just heats it up and makes it easier to evaporate into an airstream, it's that much lower. So we're talking about 0.5 kilowatt hours per kg. And with current price differential between gas and electricity, it's a marginal decrease in North America, but in the rest of the world, that would be a really significant price decrease. And again, for most of those large mining companies, they do have net zero targets that they will never achieve until they figure out how to electrified drawing. There's a similar comparison for the amine side of things on carbon capture. So number one, baseline is operating at about 130 C, and it's a mixture of amine and water, and they're using typically 1.3 megawatt hours per ton of CO2 captured. Our testing is showing us, and we're continuing to work to improve these numbers and tighten them up, but we think we're at 0.2 to 0.21 megawatt hours. So really significant reduction here. Again, you see a slight decrease in the energy cost in North America, significant energy cost in the rest of the world, and specifically Europe. So we're doing a lot of work. We've got some interest from really large research institute in Germany, as well as some other emitters and things that we're working with there. But we see a huge potential here, and that's the operating cost for energy, which is a significant piece of the cost structure, but there's also the degradation of the amine. And so at 130 C, I've been told, this is not our area of expertise, but a lot of degradation happens at that level, or significant cost-wise, small percentage-wise, but it is a cost to manage the degradation of the amine, reclaim it, recycle it. And in our case, we can operate at 80 C or lower. And so we think we'll have significantly less degradation of that solvent, make it easier to continue to reuse and have less replacement or reclamation costs. So a second layer of cost reduction that's not factored into those other two, and that one's going to be geography agnostic. I'm getting close to the end. Come on, button. There we go. So in summing up, I wanted to talk about some things that we've uncovered, and again, feeding into some of the theme of the day of how this translates to other industries and why, or how that path might evolve. What we're working on today, I call the first order benefits. So we look at things that we heat today, and we find things where we're heating part of that mass so we can be less cost. So that's our first order benefit, is we can simplify things. We can deliver energy to the molecule that actually needs the heat to go to it, and we can save money. So we can decarbonize at the same time. Second order is what in examples like with potash, when we're working with those partners and we start to go through, originally we have blinders on, we're looking at the drying process, and we just say, how much, what's coming in, what's going out of this box. And at the end, once we figure out that we can do this economically, they start asking us, well, okay, what's your exit temperature? And we could be lower than what they have today because of the amount of energy they're putting in. And they say, well, we kind of like it at that temperature because then it goes into a pelletizer and then it goes into this other thing. When we start asking more questions, why do you need that to happen at that temperature? Some of it is just because that's what it was. So they've adapted, all of these steps of the process have, to some degree, evolved around the heating mechanism. So that you've got this big pile of hot air and other forms of heat. So you made everything work. But when we start breaking it down, saying, well, why can't we just pelletize in this process? What temperature do you need for that? What moisture level do you need for that? Maybe we change this and we eliminate you reheating and reprocessing that material a second time. So there's advantages that we start to see upstream and downstream of the heating once you have a different way to deliver the energy. And then the third order is totally new processes that aren't out there right now. When we look at chemicals and pharmaceuticals, in a lot of cases, you're using steam or this other brute, some way to take combustion heat and brute force and achieve a reaction temperature that's needed between two molecules. If you can start to heat one of them directly without all the heat transfer and the infrastructure of a high pressure steam system inside a facility, maintaining that with steam engineers, all the things that takes, if you could just target the one molecule you want and get that temperature brought up to exactly where you want it, you can control it within 1/10 of a degree. We think there's going to be a lot of opportunities to change how those materials are made and eliminate, not just make this process less energy, but take energy down across the board by significant amounts. So we're looking forward to first commercializing and driving revenue out of the first one, but we see a long runway of new applications to be developed. Thank you. Thank you.
Thank you very much, Mike. So just give us a few moments while we set up for our next panel. Anybody have any questions for any of the panelists or for? No? Sure. Go ahead, Matt. Oh, okay. You might have to come to the mics because there's people online. We'll get the mics ready to go here shortly. Different kind of mic.
Hi, Mike. Thanks for that. Great to see where you guys are at. Wondering if on the amine side, if you've reached out to Initech with respect to the carbon capture conversion center for testing the technology there so everyone can see the benefits. Come on up, you got to come to the mic.
Yes, great question. Thanks, Matt. I'll pay you later. We have talked to Initech, and so that's their AIP project is essentially using microwaves for amine regeneration, and we're looking to be a second stage of that. They're building beside the HCCTC at 6 ton an hour. They're building a 1 ton an hour skid system that will run initially microwave, and then we're working to bring us in as a second stage of heating on that skid system. And before that, we hope to run through some smaller scale testing of a number of different amines, proprietary and non-proprietary, to try to see what how much better is this one or that one, or when you mix these molecules, does it change the benefit? Thanks.
Excellent. That was a nice. Thank you. You allowed us to set up. Next, I'd like to welcome to stage Scott and Patrick. Because I have to do double duty here. I'm emceeing as well as moderating. So bear with me one second.
And you're doing it great.
Oh, yes, of course, Dean and Mike.
Yeah. I've been working on this.
All right. Excellent. How was your drive in this morning? Good. Excellent. I'm glad we've got a great number of people here. We've got over 120 people registered to attend. And so I think this is pretty good attendance considering the weather. So thank you very much for coming here today. I don't know if I got to meet all of you at the beginning, but my name is Nanette Ho-Covington. I'm the executive director of the ETC Foundation, and the ETC Foundation is this floor. We are a convening space, but we also have a few other things attached to us. We have lots of nonprofits associated with us, and you'll get to introduce, or I'll get to introduce a few of these folks along the way. So you've met Dean already, and you've met Mike. Oh man, Mike, Mark, whatever. I'm calling you whatever name I can. But I get the opportunity to introduce you to two other folks that have joined the panel. And so, Patrick, may I pass it on to you to introduce yourself?
Yeah, thank you very much. For those of you who haven't had the pleasure to meet, I'm Patrick McDonald, Assistant Deputy Minister within the Environment and Protected Areas branch of the Government of Alberta. And, my team looks after air, climate, and clean technology policies. They kind of are grouped into about 3 different pieces, just to kind of summarize. And so one being, I'm sure a few of you have heard about the tier program, tier regulation. And so one, the teams on the ground implementing that, including the market compliance regulations. And then I have another team that looks after policy, whether it be, enhancing our climate policies, as well as methane policy and strategic looking how to within Canada and global leader of that. And then just to summarize, the last group would be within our partnership area. And so along with TIER comes funding. And so as a result, we're able to partner with a lot of great different agencies, corporations to really drive reductions within Alberta. And so I'll leave it at that, and we'll get into discussion more.
Oh, perfect. Thank you very much, Patrick. And we really appreciate the partnership and the collaboration that's coming out of your ministry. Next, I'd like to introduce Scott Volk.
Hi, everyone. My name is Scott Volk. I'm the Director of Emissions and Innovation at Tourmaline Oil. For people that don't know Tourmaline Oil, Tourmaline is Canada's largest natural gas producer. I know the name is a little strange given we're a natural gas producer, but we are Canada's largest natural gas producer. We also process all of our own natural gas as well, which makes us about the 4th largest midstream operator in Canada as well. When it comes to environmental initiatives and emissions reductions, we kind of look at the world as a whole. So we look at ways to reduce our impact on air, land, and soil. So we'll be focusing on air throughout the panel, but other things that are very important to Tourmaline are reducing our impact on land and water as well. So in BC, for example, we recycle about 98% of our water that we get as flowback. So that's very important to us to have a reduced impact on water. And then the same on land. We work really hard to reduce our impact on the land and also reduce the amount of waste that we produce as well. So I'll leave it at that. I suppose I should also mention that I wear multiple hats. I have the privilege of being the president of CRIN and look forward to the rest of the conversation.
That's great. And then one more role, Scott. We both serve on the PTAC board.
Yeah, there's lots more.
There's lots more. Yeah, of course. Thank you very much. Mike and Dean, do you have anything else you want to add to your bio before we begin?
No, I think
We're
I'm
good?
good. I don't know.
You're
I think
good?
we get the Accelaware background and happy to jump in as we get to the questions. Yeah.
Okay,
Thanks,
perfect.
Nanette.
And you'll notice there is an empty chair at the end. So we are waiting for Justin Reamer to arrive. He's coming in from Edmonton. So we just, it's, as you can see outside, it's going to be a bit troublesome. So Patrick, I may impose on you on a couple questions. Yeah, yeah. Yeah, so you may have to, maybe I should get you a hat so you know which one, which hat you're wearing. Yeah, move chairs. Well, anyway, I'm going to get to the first question. So this panel is about decarbonizing the oil and gas sector and, why we need to make some shifts in our industry. Scott, I'm going to throw the first question at you, if that's okay. So the first question is, how is Tourmaline approaching decarbonization in oil and gas, and what makes Canada a strong environment for innovation?
Okay. Well, we're trying to do essentially an all hands approach when it comes to decarbonizing. So for us, some of the most meaningful impacts are probably some of the least exciting ones. So probably the most meaningful impacts would be things around efficiency in operations, efficiency on compressors, utilizing waste heat wherever possible. We've got about 53 megawatts of waste heat that we recover from compressors, and that's kind of important to us to reduce our impact. So there's those pieces that have the most meaningful outcomes, but are probably some of the least exciting. When we start talking about more exciting things, Tourmaline does a lot of operations on carbon capture. So we operate a carbon capture hub just outside of Edson area. That's quite important to us, and we're doing a lot of work in developing technology and working with clean tech companies in the carbon capture space. And then probably one of our biggest areas would be in methane mitigation. So methane mitigation has been important to Tourmaline for some time. We've partnered with NGIF to start up the NGIF Emissions Testing Center, which Dean referred to in his presentation, which is a collaboration between NGIF, Tourmaline, and the University of Calgary. So lots of support from governments as well to make that testing center a place where we can test and validate testing in the clean tech space. So we are funded by the Alberta government and lucky to have that funding to keep that testing free for all the innovators like Dean that are on the stage. We also started out with funding from the federal government to kind of get up and going there as well. So why is it helpful in Canada and Alberta? I would say that collaborative approach and the kind of funding that's available. So the Alberta government's done a really good job to have tier funding available to get investment and to get innovation dollars working hard for Albertans in order to look at ways to reduce emissions in all aspects of the economy, including the oil and gas space.
Oh, that's great, Scott. In fact, a couple of weeks ago during Innovation Week, there was an investor out of Chicago. And one of the reasons why he was interested in our area and territory is because of the way Canada de-risks its technology. And so the non-dilutive funding was what interested him in ensuring that whatever he invests in has already been de-risked. So I was just giving you a bit more time, Patrick, before I threw this question at you. So you mentioned something about partnerships, and the ERA is one of your key partners. And so how does the ERA prioritize and support technologies that target these hard-to-abate sectors?
Yeah, thanks. Thanks for that. Well, and I think in terms of prioritization, understanding the challenges, right? And so, and again, Justin would speak to this in more detail than I will, but I think one of the things that we've learned is engaging with the industry, engaging with the sectors, and understanding what those challenges are and what the barriers are. And so, a lot of times when funding calls occur prior to that, there's a lot of engagement, meetings, workshopping that goes on in order to really identify what are the challenges and what would a successful program look like. And then I would say, in addition to that, as far as prioritization, a lot of times, what's top of mind, for government does have a little bit of an indication or pieces that, we're understanding, for example, last year, that there was a lot of opportunity with, necessarily within the drilling sector. And so as such, there was a program that was led off the Alberta Drilling Accelerator program, call for funding to really scope out how do we do things better there, where we do a lot of things great already, but there's always room for improvement. There's other examples of calls on that on water, on tailings management, and then again more recently, in terms of prioritization, there was a recent call for the methane, for methane. So we've made great progress in methane in Alberta. We've reduced 52% of 2014 levels, and meeting our targets, 3 years in advance of our overall target, but still recognizing that there's room for improvement. Prior to that launch, there was a lot of workshopping, a lot of where is the opportunity. And some of that, again, those learnings came from some of the government's engagement as well. We did a targeted engagement with the sectors, and in parallel to that, kind of what we heard on that engagement was issued on the website. And what we did hear, top of mind, was incentive programs really are able to drive innovation, to drive technology deployment. And so what we're trying to do is learn what we hear from the sectors and try to get that out there so we can make continued improvements.
I can double down on that, Patrick. In my previous life, I worked at Spartan Controls as the sustainability leader. Honestly, I did have more coffee. And the approachability of ERA has probably been one of the benefits of working with partner agencies. And so ERA and the government do listen to what industry needs and wants. So it's great. So this is why I'm going to lean on Dean next with this question. So how does your technology address emissions challenges in these sectors? Actually, to both you and Mike.
So as I was alluding to in our tech showcase presentation, our technology is targeting methane emissions from the sector. And I maybe glanced over quickly on the presentation, so I'll take a moment to maybe explain a little bit more about methane emissions. So methane as a greenhouse gas has a very high multiple for its greenhouse gas intensity. Depending on the time horizon, it can be anywhere between 25 to 80 times more intense than a pound or a kilogram of CO2, which is why it's very much in the crosshairs of the regulatory system. Governments are identifying this, have identified methane as low-hanging fruit in terms of how to decarbonize and actually get real impact in terms of measurable emissions reductions from the industry. So methane as a problem for the industry can be split between two types or two forms. Fugitive is a term tossed around. It basically means accidental or unintentional release. It could be from a leaking fitting, for example, and usually the solution is heavily weighted towards measurement. Let's find the source of the leak, and then once it's understood, it should be able to be addressed. The other half of the methane source is from intentional venting. So venting or release can come from chemical injection pumps, can come from methane slip, which is uncombusted methane through a variety of combustors. Our technology is focusing on methane venting from pneumatics. So these are the hundreds of thousands of valves that are running around the clock in Alberta, in BC, in Saskatchewan, and further afield that are using the natural gas itself to operate the equipment. It's not combusted. We're not getting the energy value out of the material. It's going basically straight to atmosphere after the pressure is partially used up. It's massively inefficient, and it is really a waste of product which could otherwise be kept and retained in the system. So what we've done through the collaborations and supports from ERA, CRIN, commercial partners such as Tourmaline, has been to bring a product to market that takes a venting device and turns it into non-emitting. So we can completely eliminate the methane emissions from a site in terms of its valve automation equipment. This helps producers, midstream operators, downstream operators realize the concept of a net zero facility. It is real, it is possible, and we see our equipment filling an important niche in that sector. It's important to recognize that venting pneumatics aren't just located or limited to production sites. This equipment is operated pretty much across the entire supply chain from well to point of delivery. So it is not a segmented problem. It is an industry-wide problem, and through these sorts of products like the KBA 38, an electric actuator, we can provide real tangible solutions to help operators eliminate those sources of methane release into the atmosphere.
Okay, thank you very much, Dean. Mike.
Same question. Okay,
Same.
so Accelaware and our RFXL technology, we are electrifying thermal enhanced oil recovery. So fundamentally, we reduce emissions by not having gas being burned. If we compared that typical situation in Alberta with our grid, it's about a 50% reduction today. And so that does factor in the nat gas and other combustion going on to fuel the grid. If we migrate to something cleaner, or you were able to run a solar array or wind power to feed the technology, you can get to or approach 100%. And it's one thing I'll mention is the technology, unlike a lot of other heating systems, it doesn't care if you turn it off and on. So a lot of times if we talk to operators about power cost estimates, you could curtail 5% of the day, run 95% and get a much lower cost so the grid can keep the peak, and you just reduce your cost and your distribution cost as well. The other arbitrage opportunities, if you happen to have a whole bunch of cogen, cogen power downhole at low price and sell to grid at high price.
That's great.
So yeah, there's a lot of opportunity there, and we think it's pretty great timing right now given political pressures for more production, but also decarbonization. We think we can decarbonize. We can tap into so many bypass barrels that aren't economic. If we look at the heavy oil space, post chops, thin pay, there are a lot of barrels out there that are not economically accessible with SAGD, but we can produce those and we can do it with lower emissions, and then even offer the carbon capture on the back end. So we think we have a lot of answers.
Yeah, you're leading into our nickname, which is the Et Cetera Foundation. So that's great. We're being additive. So, we can't do this without collaboration. And Scott, you mentioned during your introduction about collaboration is key. So how do collaboration with innovators and funders help you test and scale new technologies?
Yeah, I'd kind of like to point out like how unique Alberta is specifically in how much effort we put into collaborating in the innovation space. And that kind of follows the technology readiness level all the way through. I'm sure Dean can kind of talk about the examples because I could use his company as an example of that as well, where we essentially started working on collaboration with Dean and a number of other companies really early in the research phase. Then they kind of came along so funding from industry, funding from different associations like ERA and Alberta directly, NGIF, we funded directly with industry money as well early on. And then we get to early phase testing where there's collaboration with things like the UFC when we're in early phase testing at our center at the Emissions Testing Center, and then following all the way through into venture funding and being the end use customer as well. So this whole space of kind of collaboration and really focusing on everything it takes to get innovation from this thought to actually out in the field and being adopted is something that Alberta works really hard at.
That's great. And I'm a big supporter of collaboration. Justin, welcome. I'm glad you made it safely. So would you like a moment before I throw this question at you? You're ready? Okay, excellent. Justin, maybe introduce yourself quickly, seeing as that.
Sure. Emissions Reduction Alberta. Sorry, I'm late. I just drove in from Edmonton. It's beautiful out there. Wonderful roads. so a bit late. And so Emissions Reduction Alberta provides technology demonstration and risking funding in the form of non-dilutive grants. We've been doing this for over 16 years now, and we're funded by the Alberta government's carbon levy through TIER. We also do energy efficiency incentive programming. I'll leave it at that.
That's great. Thank you, Justin. Well, Patrick was able to fill in for your last question. So you wore multiple hats. But Justin, here's your question. Can you share an example of a partnership that accelerated technology adoption and how it could scale nationally?
Yeah, we have several. One of our best co-funders in the system is NRCan. So we've funded a variety of things with NRCan over the years. We have similar mandates and similar priorities. Carbon capture and sequestration would be one. We funded over 11 different pre-feasibility studies across a variety of sectors, including cement, oil and gas, fertilizer, natural gas power. NRCan also funded a number of those projects. And that collaboration, we were able to provide stacked funding to support the de-risking of a number of assessments in the feasibility end of things. Now, a lot of those have yet to achieve scale and move to final investment decision. But what we really value in those processes is we're now a heck of a lot smarter in terms of what's required technically, financially, regulatory-wise, and so forth for carbon capture sequestration to succeed in this country. And I think we've gathered quite a national database, if you will, of technical know-how and knowledge, economic know-how and knowledge around carbon capture and sequestration that has been highly effective, both feeding into the provincial government and where Patrick sits, as well as the federal government, and helping inform the regulations and policies that we have today, which are still a work in progress.
Well, thank you very much. Well, I'm going to bug Mike for this next question around innovation. And so how have partnerships helped you with adopters, funders, ERA or CRIN advance your technology?
Thanks, Nanette. Yeah, we've had a lot of collaboration, not only through the funding agencies, but then 3 operating partners on our heavy oil production pilot, but then a number of service partners and other layers of technical experts. So there was a lot to cover in getting the kind of power we're generating downhole, understanding drilling multilaterals, and then reinventing some of the downhole equipment because we're putting massive amounts of power and temperature into what was essentially a coaxial cable made out of pipe. So we had to use a lot of advanced materials that would all expand with the same rate at the same, given temperature. They couldn't break each other apart with the layers of different metals designed to deliver the energy efficiently. And we had to tap into a number of places to pull that back, not just how do you design a thing that's really nice, you can make it at surface, but now how do I make it 800 meters long and get it through this well and through this build radius in the well and have it survive. So we relied heavily on our operating partners and their drilling teams to say what could be done, as well as drilling engineers and service providers. But we needed to pull all of that together. We were very confident in our ability to design the electronics, deliver the heat, and understand how it's going to work once that whole system was in the ground. But we had to get it in the ground and had to be all connected. And
awesome. Just a reminder that older mic on the end there, the transmitter's on the bottom.
no,
So
I shouldn't do that.
you shouldn't do that. Just to let you know. My side gig is production. Can you tell? So, Dean, I'm going to ask you the exact same question around, partnerships are key. And you showed a slide with all the different partners. How do you think that has helped you advance what you're working on?
Yeah, so I'm going to pick up a comment that Scott made about TRL advancement. So I know a lot of the focus, or maybe the highlight for a lot of the participation from some of the support networks has been on the funding piece, and that is very critical. And it gets set up at the front end through a competitive process, to make sure taxpayers are getting good return on their money. But what I'm trying to get at is once established, there is project framework that brings the collaborators together into a kind of a centralized room, if you will. And that is so essential for us as an innovator to have access, particularly to the operators in the room, because, you know, designing in a vacuum, we produce engineered products, and the highest cost to make a change if we don't get it right is at the end of the process, end of the design. So to have you know, stakeholders, particularly end users and other you know, other people in the supply chain at the table early on allows us to set the requirements that actually meet the needs or meet the demands of those end users at the end of the project. So it also allows you know, people like project advisors appointed by ERA, by CRIN to have, again, their seat at the table to make sure they're advocating for what matters to them. All these voices really do matter because they're all taken into consideration for the design phase, prototyping phase. We can heavily lean on the laboratories that are made available to us to make sure we are shipping, you know, good proof of concepts to field sites. If necessary, they will be certified. And then ultimately having those live field sites like the emissions testing center is and was to us and continues to be to this day absolutely essential to be that first user experience, because that sort of old saying, nobody wants to be first, is absolutely alive and well in this industry. And that's not throwing shade or blame, that's just a reality. So having a safe, visible environment where we can deploy technology, test it, collect feedback, and then report back to the stakeholders is good, not just to close the innovation loop, but it also helps to close the confidence gap, which, you know, we found to be considerable in terms of, you know, having operators trust our equipment because it's putting their process right in line. Obviously, we're in the revenue stream. So these are, you know, these collaborations are absolutely essential to chip away, not just at getting the right product into the market, but at also helping chip away at the confidence gap in order to convince folks that it's ready to go when it hits the market.
So summarize collaboration to help you de-risk and have the customer in mind when you're actually innovating.
Absolutely.
Excellent. So Patrick, you know, you mentioned earlier about partnerships and different agencies in order to help advance things. How does government agencies and other network support services, and including infrastructure, enable cross-sectoral collaboration for scaling solutions? Sorry, that was a mouthful for me.
Yeah, that's a lot there. Try to unpack that.
Okay, we'll do it in stages. How about
Unpack that a little bit? No, that's great. You know, I think one theme I would note that kind of needs to be top of mind is just flexibility within the programs within the system, right? And you know, when we're looking at crossover between different sectors, sometimes technology is developed for one purpose, but you know, has you know, a benefit or you know, maybe applicable in another sector. And so having that flexibility of is kind of critical for one. You know, how is the government of Alberta thinking about this? I think one piece I would just note is, you know, there is going to be a continued need to lean on our partners. You know, as much as the government, again, I'm fairly new to government, but but I think what we hear sometimes from folks is, you know, we need to move faster. And sometimes it's difficult for governments given process and limitations and the need to, again, ensure funding is in the public interest. Sometimes it's difficult to move with the speed that folks need to on the innovation side. And so leaning on partners, ERA, NGIF, PTAC, CRIN. You know, we also work a lot with Alberta Innovates and we with the Municipal Climate Action Center. So leveraging those relationships to ensure that those agencies are able to meet the need and to deliver in both ways. And then the other piece I would just note that, you know, we're trying to focus on is on the information sharing. You know, went from I'm really pleased to be here today. I was, you know, trying to share Alberta story as well as at, you know, New York Climate Week, and just got back from COP 30, you know, sharing the great things that are happening here, the different ways that we're approaching it to drive these investments and to drive innovation. And another example of that is really through the International CCS Knowledge Center. Alberta has partnered with them, understanding that if the learnings can't be accessible or put out to everyone, they're not going to be able to realize those. And so that second piece is doing the work is one component, but making sure, that information where possible, obviously, if it's confidential or whatnot, not always able to be the case, but where possible, try to make sure those that need that information can access it and leverage, so they're not thinking they need to start from scratch either.
That's great. Oh, go ahead, Justin.
Can I just add to Patrick's point? Because I spent a career overlooking or helping design funding programs for innovation in the province. I'll hold it up way up here. What Patrick says is very true, that need for flexibility. So the reason a lot of government funding programs are not successful is they're over-designed, they're over-programmed, they're very rigid, and they don't adapt to change market circumstances. And that's something we really take a lot of intensive focus on at ERA. It doesn't mean anything goes and you throw a rule book out in terms of structure. But what it means is each time you go out for a funding call, you listen intently to what industry is saying, what are their pinch points, what are their barriers, what are their challenges, and how do we scope. Getting too specific and trying to pick markets, government does a bad job picking markets. It doesn't really know exactly what market is going to take off and when, and nor does a lot of the industry at many points. So we've found a lot of broad calls more successful because you can never pinpoint when a project will go at any one point in time, and you can't call the market specifically. And speed is the other point. So from funding call to funding award, we average 8 months at ERA, which sounds like a long time, but it's lightning speed in government. And we try really, really hard to keep that pace, because it's important for the innovators to have the quick no's or the quick yeses so they can move on. They might not like the no's, but at least they got a quick one and don't get dragged through a process of uncertainty for 2, 3, 4 years.
But Justin, I like the fact that even though they get a no, they get a chance to talk to you and understand why the no.
Yeah.
And so to me, that is part of the collaboration piece.
Yeah.
Not every no is a failure.
Right. And as a government funder, how you manage the no's is really, really important. So we engage every single participant who applies with a verbal debrief. And we really encourage our innovators to take advantage of those. And you may not, as an innovator, like what you hear, but you understand completely why the independent evaluation committee did not score you highly, and you got to know. And the point is, learn from that, adapt, and next time out, next year, apply, address those weaknesses, and you'll have a much better chance at funding.
And so, Scott, this is a new question, but not in here. So from a private sector standpoint, right, with all the support and funding from ERA and Tier EPA, how does that help you as an adopter?
That is almost the next question.
Oh, it is? Okay, well, there you go.
It's pretty close.
It is.
So it's helpful in many ways. I think helping the clean tech companies and helping the whole innovation ecosystem is kind of incredibly important to have those technologies available to solve kind of major problems. So I would say this whole ecosystem that Alberta has that kind of lifts up the clean tech company is really necessary for companies like Tourmaline to have those technologies available. And then we do this all together. So kind of one of those like rising tides lifts all ships type situations where we collaborate together and we don't repeat all the same mistakes and we all work together. So when we're focusing on innovation and how to have these clean technologies available to us, when we're working together and leveraging each other's funds and collaborating, we can succeed so much easier by testing a lot of things really quickly and also getting a lot of things to commercialization quickly.
Is that why you're on so many boards? I'm calling myself this. I'm on quite a few as well. So, so how do you decide when an innovation is ready for deployment then?
So this is an interesting question. So like it depends on what hat I'm wearing, obviously. But for things like the NJF Emissions Testing Center, where we're focused on methane technologies, the goal there is just speed and no barriers to entry. So we do everything possible to get technologies to test it as fast as possible. And there is just, can we do it safely? So that's essentially the whole structure of that testing center. Things that are a little earlier, we do at the U of C, and once we can do them safely, we do them at the testing center. And then once you're talking about other technologies, I have a whole team of engineers that are amazing, that are working on testing out and looking at different innovations and things like that. But Tourmaline still uses the entire ecosystem. So we use NGIF, we use PTAC, we use CRIN, we use the entire ecosystem so that we can actually see lots of technologies, do lots of trials, and kind of grow from everyone else's experience. And I really encourage everyone here to do the same thing. Like, not all the companies are lucky enough to have a whole innovation department like I have the luxury of having, but using those spaces like PTAC and CRIN and NGIF and the ETCs, plural now.
ETC.
I think those things are critically important to making all these different technologies happen and getting things to market as fast as we can and really solving major problems for the sector.
Great. And Justin, next question is to you. How does ERA help innovators move from pilot to commercial deployment and measure successful scaling? And I know there was an announcement, was it just last week before, at Spartan Controls around methane. So,
So through a variety of ways, obviously our core mandate is providing funding and providing that match 50-50 funding for late stage demonstration, typically that TRL 6 to 9 level. And we leverage much higher than on average, about 6 or 7 to 1 for every dollar we invest in our projects. But what we found over the past few years is that we're seeing more of the projects we're funding struggling and getting across the commercialization valley of death. And financing out there is tight. There's lots of regulatory and policy complexity. It's really tough to get access to an industrial site. Not every company has all the requisite talent it needs to get it over the finish line very often. So one of the things we've recently employed over the past couple of years is an innovation support service. So particularly for our startup or smaller innovators, we actually provide them with, I think it's about 60 free hours of an executive in residence time. So basically mentorship to help those companies navigate through some of their biggest challenges. And we have a number of service providers who do this for us, including Foresight, who have experts on their roster who have been there, done that, and can help a lot of these companies through hard to navigate issues. Often it's the market entry strategy that is not well formulated within these companies. And these executive in residence can support that. But we also employ the whole ecosystem, as Scott says. So one of the great things about our clean tech ecosystem in Alberta is it's very well formulated. Everyone understands whose role is what and the expertise one has. So we do a lot of warm handoffs and referrals and supports. We can also provide ideas and contacts and warm introductions for potential partners or industrial site hosts or other things. We see a lot at our level. So a lot of that work we do behind the scenes is that informal navigation and guidance.
Yeah, that's great. Foresight is joining this ETC come January, just to let you know.
Great announcement.
Woohoo! Well, sorry, Foresight, if I announced that too early. I could be in trouble later. Yeah. Oh, thank God my sister's a judge. So, oh wait, cut that. Dean, you talked about your growth, right? And so when I first got to meet you and Mike quite some time ago, it's been kind of fun watching you both grow. And so now you've expanded to the US as well. So tell me more about what the biggest challenges have been in scaling your technology beyond the initial pilots and what support is needed to expand nationally or internationally for you. Oh, actually, I got to see you at Sarah Week too last year in Pitch.
That's right. Yes. We were invited down through the Canada House initiative, which was great. So barriers to entry. Yeah, this is a great question. I think, last question was on collaboration, how to get a product to market, how to get the TRL advanced. I think all of that is in place in Alberta, and it's well developed, and it is the right path for a company like ours to take to bring a technology to market. Having said that, that basically puts you on the precipice of that valley of death, which currently it is real. Market adoption risk is real, and people need to recognize that market adoption risk is a barrier for investment that we might want to attract in order to scale our company. So crossing that chasm is a real challenge for innovator companies. It's not necessarily the role for government to pay their way through it, because truly industry has to kind of, I'll say, reach a little bit over that gap and shake the hand of the innovator and help them pull it over. So that comes in the form of champions at these companies that can help bring technology into their organizations. And for us, it's a win-win. The innovator company, is able to address market adoption risk, while the other company benefits from being, maybe not first mover because it's been demonstrated, but second mover advantage means you don't take on the technology risk that's been mitigated, but you do get the benefits of the efficiencies. You're now sooner to market with essentially what should be giving you competitive advantage. So while not just addressing methane emissions, we are also looking at enhancing facility efficiencies to help bottom line. So innovators are laser focused on your bottom line, but really we fight do nothing every day. Do nothing is a completely plausible and viable, in some case, position for operators to take. So how to address do nothing? It's being done in a couple of ways. I think you set up, Justin, for a good question, which was the methane program that you just announced. What's the official name for it?
Good one. Methane emissions reduction program. I got a lot
Sorry, I didn't mean to put you on the spot there.
No, I got a lot of acronyms in my head.
Okay, so here is a program that is for operators that can help put as much as $1 million into project financing to reduce methane abatement projects up to 50% of total costs. Hopefully, I got that.
Yeah, I have a marketing job for you if you're interested.
Well, if it's a successful program, hopefully I won't need that job. So that's one aspect. So there's now money available on the table today for all the operators in the room and calling in to access. So I'd highly encourage you to either reach out to ERA, or if you've already got a methane abatement program in mind or technology, talk to your innovators. They can help walk you through the door and really reduce your funding. The other piece is regulations. At the moment, we're seeing Saskatchewan as leading the methane abatement regulatory environment. We are laser focused on potential upcoming regulations that might be coming in Alberta, because we see the real current emissions problem is not greenfield, it's brownfield. This is the source of emissions. Currently, do nothing policy is still alive and well with the current regulatory framework. So if that changes, I expect to see a lot of action in this province in the coming year. If it stays put, then it's going to be, I'll say, a mixed bag. So really interested to see how things play out there.
Okay, cool. Mike, how do you cross the chasm?
It's a really good question, and definitely there's solid doses of do nothing out there. I think we go back to that first slide I put up with the timeline. Some of our challenges, having gone through, this is probably the third cycle of change, major change in the industry. And so the champions are fantastic, but when the champion or the champions team disappear since last week to this week, you lose literally years of time in building that progress to try to get all the way to TRL9. So definitely a challenge. I think, from the sound of it, the methane program is great. It's something we've wished for. Is TIER exists. There's an incentive long-term for an operator to decarbonize, but it isn't very catchy. It doesn't motivate somebody who's working on an asset and they have a bonus for production and don't mess with my asset.
Right.
So it needs to be stickier or stronger to pull someone in and say, okay, it is worth, we want to do this because we can see a payback in shorter period of time or something. We've been very successful in getting the grant funding that helps us get there. It's been harder to secure the operator financial support. So that's a challenge for us. And as is the timescale, we're changing a big thing. We're changing the way we produce heavy oil. And so there's a lot of invested dollars, huge infrastructure, hard to change. So that timescale gets hard. And I guess the honest truth is, in some ways, we've diversified to survive that. you know, you talk to an investor, they say, focus, focus, focus. And when we say, well, we can't wait 3 years if things slow down and nothing happens and
Right.
then we come back, we can't wait. So we needed to spread into 2 other giant industries to try to get some, smooth out the curves.
Right. And we've seen Alberta industries diversify. We've had a graduate from here, VL Energy, diversify into ag now from energy. So I think diversification is great. And the opportunity to be able to apply your solutions in more than one location is great. So we'll talk about barriers because Dean, you said earlier, the complexity is there. The real world challenges are there around regulatory market risk and capital access. So Justin, this is for you. What are the main barriers innovators face and how does ERA help mitigate them? You've kind of mentioned something along the way
Yeah,
already.
kind of referred to that again. So obviously, capital and financing in which we play a role, but it's still very tight out there. We have a very conservative financial sector in this country, and not as much risk capital as we would like to see, perhaps like south of the border. But because of all of the shifting policy dynamics regarding decarbonization and a variety of interplays between federal and provincial governments, there's a host of uncertainties that are holding a lot of companies back from investing in new technologies in this space. Again, I talked about talent is a big one that a lot of companies don't necessarily do a complete 360 and evaluate what is the actual skill set I need to take me across the finish line, and getting the requisite talent on board into various companies, particularly if you're small, is really, really challenging. But it's an absolute area, a must to evaluate and ensure you're bringing in as much talent as possible. I think, what a lot of the successful companies are willing to share, are willing to talk to other players in the field and work in partnership and in collaboration with others. Those that try and do it in a very protective, isolated, siloed, I need to protect my IP at all costs and I won't let anybody in the tent, often will not get the successful traction because they are missing out on a variety of partnerships, collaboration opportunities, and just wisdom and guidance from others that can support them along that journey. So that's something we try to encourage at ERA is that knowledge sharing, the partnerships and the collaborations. A lot of the startups have to have a partner such as an industrial site host to do their demonstrations, which is not easy to do. So we're looking at how do we open up further industrial sites? How do we engender more willingness on our major industrial facilities to be willing to bring in these new technologies and try? It's hard when a company's making money. They don't want to shut the thing down and put a big risk at them for reduced production or some sort of cataclysmic event. So how do you get beyond those fears and engender more industrial trials is something we collectively as an ecosystem and governments need to work on.
Thank you, Justin. I'm going to double down on the talent piece. So I serve as an advisor to a couple of post-secondaries. I am on too many committees, one for McPhail and one for Schulich School of Engineering. And I know how tough it is to get into schools now. Engineering, you need a 90+ average to get into engineering because they only have 800 spots. And so they've run out of space and they need more space. And I see that as the biggest risk in the future. If we want to deploy technology and advance Canada as a superpower, we need to actually have people coming out of the schools that are actually wanting to be in the energy sector. So, okay, that was my soapbox. I'm off my soapbox. Patrick, we talked about regulatory improvement. So what can we do to improve our regulatory processes or investments and partnership frameworks to accelerate Canada's clean tech adoption?
Okay, thanks. Thanks for that question. Where can we improve? And maybe I'll just start with kind of the Alberta system and some opportunities there. And I would just note there's as much as folks strive to have the perfect system, there's obviously always room for improvement. And that's been the tier program, which has went through a variety of names over the years since 2007, since it was kind of the inception of it. And it's went through a number of tweaks as well. But the key elements as far as an emission price as well as a market, those things have maintained. But it is very important to understand where economies are at, where sectors are at, to ensure that there's appropriate balance there. But I think the one focus right now is, how do we provide certainty? Justin just noted that, uncertainty is one of the things that is a huge barrier to the degree possible as far as funding programs or even the program itself. How do we implement where we can elements of certainty so that if folks are wanting to do a program or an investment, they're not waiting for 2 years to understand whether or not they are going to get accessibility to that. It makes it difficult to make decisions, to put that in front of boards. And so trying to, where we know technology is proven and emission reductions are practical and available, how do we ensure that there's a higher degree of certainty that if folks invest the money or do undertake the program, that they can get a return on their investment. And that's kind of one of the biggest things that we're finding is, certainty on the upfront capital, but as well longer term certainty on revenues, because that's one thing is, even after getting things built, there's operational costs, there's a number of elements in there, and the longer and more things that we can try to de-risk. Obviously, we can't de-risk everything in terms of programming, but where we can try to help matters, so to give both innovators, entrepreneurs, and operators understanding of if they undertake this action, they can expect this result. We're going to be better off and get more programs, more projects built, and have better results overall.
That's great. I'm just looking at the clock, and we got 3 minutes for this final sector around how Alberta is driving the national progress, and how do we, as Alberta, show off to the world that our model works and how we provide national leadership. So, Scott, I'm going to just throw this question at you. What lessons from our experience in Western Canada could benefit energy producers in other provinces?
So I would say this kind of approach where it takes everybody and to try everything, I think, is what Alberta does really well. And it really is needed. Like the ecosystem needs CRIN and Avatar and PTAC and all these different pieces. We really do need them to be successful. It's not in some of the other provinces. I think probably part of the reason Dean got on an airplane today to come here is because it's not in his home province quite as much, at least. So I think it is something that we have that we should be quite proud of, and we should get out into the rest of Canada as well.
So is there a recipe for our magic sauce then?
It's everything. Like I get the frustration with the do nothing kind of piece. But when you're a producer and adopter, doing everything isn't necessarily possible either, because it would be X number of times more than our market cap if I did everything that came from a clean tech company. But it is do a lot, and it does mean do a lot and use all the different ecosystems that exist in Alberta, which ERA, Alberta Innovates, kind of all the different systems are absolutely necessary to achieve what we're trying to look to do.
So Justin, this is the final question. How can the Alberta collaborative model be replicated across Canada to accelerate clean technology adoption?
So just building on Scott, in terms of the ingredients of success for Alberta, I think are a few things. We obviously have the resource here. We have a critical mass of talent in a variety of different areas to actually do the things and make things go. And then we have the funding in both from a government funding as well as capital funding to facilitate the adoption. I don't think you can, nor should you try to replicate that in every single province. I don't think it's possible. Other provinces have other sectoral expertise and critical mass, Ontario finance or IT or tech. So how do we enable the rest of Canada to draw on the infrastructure and capacity here? CRIN is national, PTAC is national, ERA. We can actually invest in companies across Canada and across the world. They just need to have some demonstrable benefits back to Alberta. So I think we've seen Alberta's driven clean technology success like no other across the country. And we want to share those learnings and success and sort of open our arms and say, come on in, any energy innovator or producer, utilize our infrastructure, utilize the expertise of the ecosystem, and let's see, many hands lift the boats, or whatever the saying is. I messed that up royally, but I like it. It sounds good. So I think that's really the approach we need to have. Likewise, finance startups here should use Ontario's infrastructure and ecosystem and expertise to do their thing.
Oh, perfect. Patrick, do you have anything else to add before we close anything off? Anybody have any, we're beyond time. So any last minute comments, anyone? Anyway, thank you very much. I appreciate being asked by CRIN to support today's event. If you're not a member, there are QR codes around the room where you can become a member. And I know there's a new tech challenge coming out of CRIN very soon for any of the innovators online or in person. Thank you very much for your time.
Thank you.